you have ever tried to use an AI tool to answer a question about a medical guideline, you have probably run into two problems. First, the AI gives you a confident answer, but you have no idea if it is actually in your source document. That's hallucination. Second, even if the answer is correct, but you can't trace it back to the specific page of your source or a section of your source, that means there is no audit trail. In clinical settings, that's not good enough. If a decision is made based on AI output, someone needs to be able to verify exactly where that information came from. That's what Guideline Copilot solves. Guideline Copilot is a RAG system. A RAG is a retrieval augmented generation. It built specifically for public medical guidelines. You upload a guideline PDF, ask a question, get a grounded answer with exact citations like document ID, page number, chunk ID, and similarity score. Every single answer is traceable. If the information is not there in the document, the system tells you it does not know rather than making things up. That means avoiding hallucinations. Let me show you how it works. Let's start with ingesting some files. So you say you go upload. So we are going to try upload WHO guidelines on hand hygiene in healthcare. That's a 270 page clinical guideline document. It's 4.3 megabytes. Let's upload. So I have already keep it downloaded. You can see it. It's 4.3 MB. So let's fill these fields. So source and category. Let's say it's a let's click on ingest. We can see it's processing. You can see the embedding chunks is happening like it's 50 out of 1792 chunks. Like the entire document what we uploaded of 4.3 MB, it's of 200 plus pages. So it become into 1792 chunks. So it's already processed 650. So it's almost 1500. Yeah, we are about to finish. Yeah, it's done. So you can see it's done and it ingested 270 pages and 1792 chunks. You can see it created a document ID, the title, source, and category that we have given. Just to check if it accepts the duplicates or not. If you try to upload the same document again, so just say again, and if you try to ingest it, so it says it's duplicate detected. So reusing the same document, it don't take the same, so it identify the existing one. Even though you refresh the page and then you try to give the same document again, so you try to ingest it, so it says duplicate detected. So it already have and processed it. You can see we didn't give the title etc. It identified because we used SHA-256 hashing. So here it took the same previously what we have uploaded. Now let's move to asking some question on our source document. So we can just choose the previous. You can click on this button, use last document. or else you can say drop down also the same document that we have uploaded, and we can type some questions here. Let's start with a direct factual query, something like what are the 5 moments for hand hygiene? As this document is about hand hygiene, let's see its answer. So it gave word by word uh, answering just like ChatGPT. Okay, the answer is it listed the 5 moments, and it's pointing to this. This is the doc ID and this is the page number 131 where it found this answer. It just not pointing out to this page, it also giving the full citation. It's like the document ID and then the document page and then chunk ID and then its similarity score. So these chunks are ordered in the descending order of similarity score. You see the highest similarity score is 0.64 for this chunk, and which is a strong semantic match. Okay, let's test with another query. Let's ask something about finding a number. So if you see, it's more specific to a number, asking duration for hand rubbing. So let's see what it is saying. It's saying 20 to 30 seconds. The system found that specific information in a 270 page document. It's under 2 seconds. Now let's ask the other question, which is matters most for any medical AI system, which is testing the hallucinations. So this medical guideline that we uploaded, which was published in 2009. So we are asking the question about COVID-19, which doesn't exist by that time. Let's see what happens when we ask about it. I don't know based on the provided guidelines. That's exactly right. The system didn't make something up. It didn't pull information from general medical knowledge. It just checked the document that we uploaded and it found nothing, and it's saying I don't know. That is the exact answer that we are looking for. There's a difference between a trustworthy medical AI tool and a dangerous one which hallucinates. Let's say if we switch the mode, no rag mode. So and ask the same question now. Now it answers with general COVID information. Useful in some context, but there is no citations if you could see. No document grounding and no guarantee it's relevant to this specific guideline or not. That is like that is the contrast that makes the value of RAG very clear. What we are trying to say is, so if you could recall, in the beginning we talked about two problems with AI tools. One is hallucination, which we just tested, and then the other one is the audit trails. Oh, I just didn't change the mode. So the second one is the audit trail. Uh, so if you go to evidence, this is the most important for anyone deploying AI in clinical or regulated context. The evidence page shows the complete audit trail for the last query, the exact question that we asked, and the um, the complete audit like doc ID, page number, chunk ID, the similarity score, and the uh, chunk. This is not a black box. Every output is traceable, verifiable, and auditable. If a clinician or reviewer ever questions any answer, you can show them precisely what the model actually saw, and and why it said what it said. This is the complete audit trail. Next feature is summarization. Summarization, instead of asking specific questions, you ask the system to summarize the entire guideline in different formats optimized for different readers. You can see TLDR, key steps, contradictions, and eligibility. So let's click on this. This is TLDR. It gives you the key purpose, main recommendations, and critical warnings in a few bullet points. So you can see it give you the summary of WHO guidelines on hand hygiene in healthcare, what is its purpose, and key recommendations, clinical warnings, etc. And as usual, the citations. Just quick overview before reading the full document. Key steps gives you an actionable number sequence like the implementation workflow. It says construct some action plan, ensure some supplies, educate healthcare workers, promote since care, repeat the cycle, focus on key moments, etc. Okay, let's move to the contradictions. The contradictions, the contradictions groups the warnings by theme. Let's say medications and products, conditions and situations. You can see use caution, avoid something. So this is about contradictions. Then eligibility. Eligibility gives you the criteria in a clinical format. Just say engage in activities that requires hand hygiene, such as performing invasive procedures, any direct patient contact. Every summary comes with a full citation table, so you can verify every point against the source document. Let me show you a few most interesting parts of the code. Uh, One among them is the streaming answer. So if you see this function streaming answer, we are using OpenAI API for as an LLM. So with OpenAI API, we get this option enabling streaming. So you just say stream equal to true so that we enable streaming. So as LLM generates the output, uh, and then we take it and pass it to FastAPI. We say stream is equal true in the OpenAPI call, and instead of waiting for the full response, we get chunks as they generated. Each chunk is yield. See, each chunk is yield, and then FastAPI stream it. So the UI consumes it and update the placeholder on every token. At the end, we yield the citations as a JSON line with a sentinel marker. So the UI knows when the answer is done and the citations begin. Okay, the next one is the batch embedding. This is about upsert chunks into vector DB. This is the batch processing loop. So we process here the batch size is 50 chunks time rather than sending all 1792 92 chunks at once. We just process it in 50 chunks. So after each batch, we update the job registry with the indexed count. Uh, that's what feeds the process bar. If you remember in the UI, when you upload the big file, it shows these many chunks. It just uploaded. Okay. Next one is the async pattern and the ingest endpoint itself. So here the background task is FastAPI's built-in mechanism for running work after a response is sent. The endpoint, this endpoint registers the job, saves the file asynchronously because you can look at it. We make use of background tasks and we registers the job asynchronously using the run in executor. Can you see it? Run in executor. Then returns the job ID immediately with the accepted status. Run in executor. So we are using background task. So we use run ingest. So what run ingest does? See, it just is so the extraction, chunking, embedding, everything happens in the background function run ingest, completely decoupled from the HTTP request. That is one last thing is the GitHub Actions CI. Every pull request triggers uh, two checks. You can see here in GitHub Actions, it checks two. So if you go back, so you each time we just commit it. So you can see there are two things happening. One is lint and test, and second one is Docker build. The main is always in a deployable state. So we used this pre-commit hook, which auto formats with rough on every commit. So CI failures from formatting are essentially impossible now. So where do we go from here? A few things on the roadmap. First, semantic chunking. Right now, the chunks are split at fixed character boundaries, which sometimes cuts mid sentences. In the current project, we have chunk size is equals to 900 characters and chunk overlap 150 characters. But splitting at sentences or paragraph boundaries would improve retrieval quality using semantic chunking. Second, across encoder re-ranker. After the initial vector retrieval, a second model rescores the chunks for precision. That's a standard production pattern for high stake RAG applications. Third one is authentication. JWT based access control before this could be deployed to any real environment. Fourth is the better OCR for scanning PDFs. For now, we have PDF parser. Uh, Sometimes it's not good enough. So the better OCR will help. And fifth one is streaming summarization, just to match the streaming experience on the ask page. The full source code is on GitHub. If you can see, is all in GitHub and it is publicly available. So if you are building a RAG system and want to see how to handle large document ingestion, streaming responses, citation trials, async job patterns, the code is all is here. The core lesson from this project is that uh, the RAG for high stake domains is not just about getting the right answer. It's about being able to provide where that answer came from. Evidence first retrieval, Strict grounding prompts and a full audit trail are not nice to haves in medical AI. They are the minimum bar for trust. That is all for this video. Thanks for watching. If you found this useful, subscribe for more AI engineering content. The link to the repo and the full write up are in the description.